Hi, so now let's dive into the topic RR. In RR, same as we have done SRTF, time quantum will be given. So if time quantum is not given, you have to take it as 1. So, but for sure, time quantum will be given to make it a tricky question. For now, we're taking time quantum as 2, and RR is somewhat tricky, and we have to draw two charts for this. Okay, we have to initially draw two charts for this. I'll tell you what all are they. One will be your RQ, that is ready queue. Okay, it is ready to go forward, and the next one is our Gantt chart. This is a very tricky sum. I hope I want you to hear it to be very closely, because I'm going to explain you a small trick here which will relevantly be easy to finally get your CT very fast. Okay, very fast. So what you do now is, now write P1 is 1. P1 is initially 80 is our initial time, so of course we're going to take 0 P1, and P1 our initial time is 2. Okay, P1 our initial time is 2. So now P1 is written P1. Now what will be your least arrival time before 2? Least arrival time is 1 and 2. So now write P2 and P3 here. P2 and P3, because by 2 already 1 and 2 has already arrived. 2 is also equal, so we can write equal is also fine. 1 and 2 has already arrived. So now here 4 and here 2. Okay, so 4 here will be 2 here, minus, we have to minus 2 because time quantum minus 2, and here 0. So now we have to write P2 value as, add 2, that is 4, and P3 we have to just add 2 here, that is 6. Okay, now P2 is done, P3 is done, and now complete P3 is 0, so P3 is eliminated. Okay, P3 is eliminated. 2 cross is elimination. Okay, now what all are left? What all are left on the queue? What all are left on the queue? We have P1, we have P4, and then comes P2, because highest least values comes, and then comes P2. Now this P1 comes. Now P1, we didn't do P1, so P1, P4, and P2. Okay, now P1 is left, P4 is left. Again, after P1, after P2, again we have to write P4. Okay, because we have considered the value of P2 at 4, initially at 4, the P4 at initially at 4, which what we take, I'll tell you this as a reference, because at P2, when this becomes 2 1, what will be the least arrival time? Least arrival time, 0. So 0, that is the reason why we take this. Don't confuse. I'm going to tell you again and again. First write P1, that is the least arrival time. Of course you have to write P1 for sure, that is 2. Next, the least arrival time, by 2 arrived, what all trains has arrived? P2 is arrived, P3 is arrived, P4 is waiting on the list, is not arrived yet. So after doing this step where I wrote this, after that we have to write again what is again ready to arrive. What is ready to arrive? P1 is ready, P4 is ready, and P2 is ready. So now P1, we have to write P1 here, just add 2 again, that becomes 8, and P4 you just add 2 again and it becomes 9, and P2 you add 2 again to it and becomes 9, 10, 11. Okay, so now P1 minus 2, that is 3. Okay, sorry, that becomes 3. Okay, now 3, and what P4, what is the value of P4? P4 we have 1, so 1 initially becomes 0, and at P2 it is 2 and it becomes 0. So here is a small twist now that you have to keep in your mind, that P1 value you have to minus it when you are taking it here itself. Okay, so that becomes 1 now. Okay, and this will also be minus. So this will be our BT, that is 100, and after that our Gantt chart is this is our Gantt chart, and initially our P2 value, I'll write the Gantt chart here again just for a small reference. The neat Gantt chart. P1 is 2, P2 is 11, P3 is 6, and P4 is 9, and sorry, P1 is not to 8. We have to very much concentrate on this, not write all this wrong, and I'm going to explain you again a small reference of how it is done. First we have to write the Ruddy Q chart. First P1, because 2 is the initial time P1. When P1 has arrived, that is at 2, what all has arrived before itself? P1, P2 is arrived, and P3 is arrived. So we have written P2 and P3. Done. So down near the Gantt chart, we have to write P1 initially 2 and strike of 5 and minus 2, that is 3. So done. P2 we have to write strike here, and we have to write add 2 to the next number, that is 4. This is a small trick. Okay, this is a small trick. We have to add 2. I mean, this is how initially it has been done. Add 2, and next initially same for 3. Strike the value here and write your next value here. After this, what all are left out? What all are left out? Because when we strike 5 here and write 3, what all is ready? What all are waiting when it is 2? What all are waiting when it is 2? We've done P2 and P3 is completely done again. Now the queue goes to P1. Okay, P1, at P1 it is waiting. At P1 the arrival time is 0, so it goes to BT, estimated arrival time. At estimated arrival time it is 3, because 3 is bigger than 2, so it is waiting. So we have to write the waiting chart here. P1, it is waiting, and next P4 is also waiting. Then initially comes P2. Okay, I have a doubt now. Why are we taking P1 first, P4? Why can't we take P1, P2 and P4? That is a very intelligent question. So you have to compare this to this initial time in the starting. If this initial time is not matching and bigger than this, then you have to skip to this. Okay, and then you get your initial arrival time. That is the reason why we have written P2 in the last, because P2, when P2 1 is already arrived, what all is estimated to be arrived is 2. So we have to write this in a big order, 3 and the big number, and then, so why I have written 4 is by 2, 3 is already waiting. We don't want BT now. BT we don't want. We don't consider about BT, because we have all at arrival time 3, it is already waiting. Okay, so this is the biggest one. So it goes on like this. P1 is waiting, 3, it is waiting. P4 is waiting, 3, it is waiting. Next, what all is left? P3 is initially become 0 and P2 is left over, so we write P2 in the end. That's it, as simple as it is. So I've completed this explanation. If there is any doubts, truly catch out me on Classroom, Google Classroom. Thank you.